Well, guys, this shot is very cool because we are doing RBD destruction, we are clustering some smoke simulations, we're moving some rocks, we're doing a bunch of things. So, to begin with, it all starts on actually how to make a house. In order for this, to make the RBD, I'm going to show you briefly how this house tool is made. Um, Well, the key part of this house tool is that you can actually change the size, the windows, the chimneys, the roof tiles, etc. on how it's made. So I'm going to show you some parts that you might find interesting on how this tool was made. So to begin with, I'm going to turn the chimney high to off, and I'm going to turn the roof tiles to low, and I want boolean. So these are the roof tiles. This is just a visualization, and as you can see, I could change the side to something else, and it changes automatically. I could change the size of the plant size, and boom, now it's super big. So you can change a bunch of things, right? Even if I will go to the roof tiles, the no wait, if I go to here, I think the cover. Oh, here, the curve. If I go and set it to 0, I'm basically changing how this looks, which is very nice. Let's go to -1, and let's open this and dive in. So, I'm going to show you the beginning and the roof styles to begin with. So, the beginning is basically a grid where I scatter some points and I copy the grid itself, as you can see. And with a simple match size, like so, I'm going to do a boolean where I am going to intersect these guys together. So I'm going to get like this kind of shape. Then if I were to go and do a union, see, this is all separated, and with this I could just select all of it and I could divide, so I can just remove the unshared edges. As you can see, now I don't have any kind of polygon anywhere. I can start with the first part, which is just extruding this upwards, and then doing the necessary groups, like for example the up part, where then I'm going to just add UVs, and I'm going to separate the up from the rest, and this is going to be the first floor, and all the things that are going to happen to the first floor are going to happen here, which is adding the door, adding some windows, etc. So on the first part, now we're going to have the ground of the second floor, which is basically going to be expanded a little bit. It just, I'm going to add a normal. I'm going to transfer the normals of this poly extrude. I'm going to then grab the points that are facing a certain angle, which is in this case positive set. And I'm going to just move it to where I want, right? So I'm just moving it. So this is the first part, and then I can go here and I can do exactly the same, poly extrude, UV walls, and it's the same process. It's like it's iterative. These are the panels, and I can divide this. I don't know if I'm using this. Yes, I'm using this. So basically, I'm just boolean a window that I made, and I'm booleaning it on whether they are, and I'm just creating the holes. And how these are made, it's basically with this setup where I'm scattering points on the wall. So I have these walls, I'm using a facet so I can divide each wall on its own. Then I'm promoting the normals, and then I'm basically separating the walls that are facing on the x-axis to the z-axis. I'm just creating two groups. And if I go even further, I'm separating everything based on these groups. I'm fusing as much as possible, and then I am just insetting this so I can have this shape where I'm going to be using it for the scatter. As you can see, this is what I'm going to be using for the scatter. I initially had this, and now I have this. Then I'm going to transform everything, blasting, and I'm transforming. All I'm doing is using this function, centroid. I can get the centroid of each guy, and I'm just setting this to 0. So I can have a line, because probably when I'm just fusing, or I'm going to have an activity and then fusing, sorting, and adding, I will have a line where I will be using it for the scatter. If I fuse this again and I split based on groups, I could do the scatters. In this case, I have three windows, and all around here I have more windows. If I fuse them even more, now I only have 1, 2, 3, 4, 5 windows where I can copy these guys. Well, this is it. These are all the windows. So you see that only with some scatter and normals and points I can create stuff. But let's go to the roof tiles. Remember, this is a really big setup, so if you are curious on how this was made, we can do a proper workshop on this. But as for now, it is not really the point of this effects workshop. Anyway, the roof tiles section is actually very good. So the roof tiles, this is our roof, which we created on later on in the house. And what we are doing, let me just go to roof tiles. Okay, it was around here. Okay, so how do we create this roof? So basically, once you have any kind of shape that you want, make sure it's aligned on the x-axis, split based on one direction. In this case, on one direction that's going to the set positive side. This is the left side. So what I'm going to be doing is to create a line, resampling it based on how many roofed tiles I want. I'm going to match it based on the bounding box of this guy, and I'm going to match it again once more. See? This is what I'm doing. I'm just placing it roughly where I want. With this, I'm going to do the other way around, where I'm going to create a line that goes from left to right, and I'm going to call this the width of my roof tile, and I'm just going to copy and paste these lines. And then if I write this downwards, this is what I'm going to be having. Very, very nice. And this is going to be the length of my roof tile. I'm going to create an attribute for my normals. Basically, I'm jittering based on min x and min or max x, and all the directions. I should have used an orient, which is way faster for this, but back then I didn't know better and I used this. So this could be totally improved. I'm going to match size again, so it's center, but I'm also going to store this function later on, because I'm going to be transforming this. It's better to just work on the center of the grid. Then I do have a roof tile right here, where I'm going to also match the size. I'm going to tilt it a little bit, because I need this to be tilted just a tiny bit. And this is where I switch between low and high res. And I'm just going to copy and paste this. So it was all done. Remember, I'm using the tangent as the normal. So if I remove this, I'm just not going to have what I need. And if I remove this, I'm not going to have variation. So with these two things, I'm changing everything, as you can see. Very nice. Then if I promote the X from point to detail, and I mirror this, because I know my houses are the same both ways, I can match size this again with the X form which I had before here. See? And these are the roof tiles from the watcher, the roof tiles again. So what's different from this to this? This is the setup outside, and this is inside. You will see there are some variations. So the difference is that I put everything inside a for each loop, where I am selecting a bunch of different roof tiles. So this is the normal one, this is with some holes, this is with more holes, and this is with even more holes. And the difference thing that I made is, hey, to select whether I want the roof tile to be this one or inverted. That's the only difference, that this is mirrored. And that's about it. So basically, I'm creating an attribute here where I have the variant and I have the flip. If the flip is 0 or 1, it's going to change here based on the flip. But if the variant changes, I also have a high probability of that all the variant number 4 is chosen. I'm going to just choose inside here, basically the point 0, 1, 2, or 3. So that's all I did with this setup. All is done here, and all the references are coming from the for each begin. The same for here. This is just the low toggle. And I'm doing the same trick of promoting the attribute, unpacking, mirroring, match sizing. That's all I'm doing here. Well, having this in mind, I created 4 different houses where I then placed where I wanted. This is it. Let me show you. This is it. There was some minor bugs with some part of the house, which I removed. Very nice. Remember, everything is with a reference, so I had to tilt some stuff, so not everything is what appears. It's the same, you can just lie, but it works. Then this is where it begins. Here's where I start to do the actual fracturing. And I had to be very very organized with this. So firstly, I'm going to separate this because I know I'm going to be fracturing this. I'm going to be saving the name. I always like to work with this. As you can see, this is called wood roof. I'm saving the name original too because I need it later on. I'm creating again the wood roof name or each, so you can have different numbers right here. These numbers will refer to the amount of different pieces I have. In this case, it appears that I have 15 pieces. If I were to see this, it will look something like this. So I'm going to go per piece here. I'm going to add a cutter and a shutter wool. This was a tool I made a while back ago. I believe this tool was made a couple of years ago, but the overall setup for this tool is just to do the following. It's just to do an ISO offset. Usually you want to do an ISO offset with more resolution. You want to scatter some points here. When you scatter these points, you will want to then copy to points some grids, right? You're going to copy some grid, but you will see that this grid is not aligned to the object, or it's not working. So you want to randomize the normal. You will do this with the normal, and you will just do direction orientation. Now everything is random. And you also want to add a mountain right here. Now the problem with this is that you are wasting a lot of space. So another thing that you want to do is to do a group. You want to group all your primitives, or in this case you would like to do points instead, but you would like to group all your points that are between this volume. So you will disable this bounding box and do by volume. It also appears that we don't have so much resolution, so let's do 20 by 20. Let's go back again here, and let's convert this to BDB because I think we should go with BDBs. So yeah, the volume is pretty small right now. So what we should be doing is probably do instead convert BDB, move here, convert this, BDB from polygons. Now that you have this, you can fill interior and start expanding this a little. So you can have some like outer edge. You'll see now you have a point, and what you want to do is to reshape the STF. With this reshape, you will start like getting more and more points. Now that you have these points selected, you want to promote these groups from points to primitive. Sorry, you want to group promote this again from points to primitive. This the group 6, and now you have this. And you do want to invert the result of this group so you can have a more optimized shape. with a simple Boolean factor. You can then use this as the cutter and use this as the main shape, and you will see it's real fast. But imagine you didn't do this. This is a little bit slower. It's a little bit slower, but it still works. But if you have way more resolution, it will be cost efficient. Let's say we have a divide right here, and let's say we have a mountain under this guy. Now we have this. This is starting to become a little bit slow. This is even slower. Now imagine we don't have this blast. Look how slower it is versus this. This is super fast, and I'll do this without it. Super slow. But that's about it. That's all it's happening right now. There's not much to it. That's all it's doing between this cutter. See, it's exactly the same, and this shutter. The shutter is just ignoring this. This is what we did with the VDB reshape and trimming area. It's just doing a volume fracture. The volume fracture, remember guys, if you already have a name, you want to select a couple of things. Firstly, you want to append this and have this set to that. And instead of detriangulate all polygons, you want to have no polygons, like here, no polygons. What this is going to be doing is to add these kind of triangulations to the edges, so it's better for your rendering engine later on. Also, if you want to transfer like the UVs of a plane, you can use this and transfer the UVs if you were to have. Once that you have this, it's going to do that for every single piece. We have everything fractured as we want. We are going to use the wood roof again as our original name, so everything is called wood roof, and then we're going to assemble this to pieces. With a frustum, we're going to be selecting our camera, and we should be deleting everything that's not inside, because we don't need all the pieces that we are not actually watching. All of this can be just taken off. We're going to be dividing this again. These are the high res. We're going to be poly reducing this so we can be more efficient in the simulation. And then going to assemble this, and now we have both things, the high res and the low res. This is the low res, and this is the high res. While we're doing similar things, let's begin with the separation. We are separating this based on names, as you can see. These are all just separations. And this is what I'm not going to be fracturing. I don't need to do anything else with this. These are the windows where we are doing exactly the same process. We are setting the names of the windshields, so we can have everything different. We're blasting everything that is not what I want, which I only needed this, so I selected them by hand. And with the for each, I'm going to pull extrude a little bit. I'm going to reverse, and I'm going to do our RBD material fracture, and then I'm going to assemble this as so, and I'm going to transfer the name origin and name origin too. This is the same process as before, and then I'm going to just simply have these windows. If I were to do an exploded view of this is how it will look. The settings I used in the material factory is just having impact points, and I actually didn't change anything. I just set glass and it worked. Okay, this is quite messy, but you will see how it works. So I have all these exoskeleton. I'm going to do the same process, wood, planks, roof. This is how it's going to be called. I'm going to do a bunch of things here. To begin with, this is all fixing, because we need to fix the shapes. This is a measure fracture. What I'm doing is to separating everything based on what's big and what's small. It's just I'm calculating with this node the vector of the bounding box. So the bigger the shape, the bigger the bounding box is going to be. I'm going to get this value, which is the multiplication of all the axes. And then I'm just going to separate everything. Hey, the bounding box is less than the threshold, then you're going to be separated with a split. The same for the area, which is just calculating the area right here. The same is for the volume, which is calculated here. I'm going to be plotting a bunch of things that I just didn't like, which are those ones. I'm going to be filtering everything that I'm not actually watching, as you can see. And also resetting the names. I'm doing a bunch of booleans on places that I think they should be separated, like this one. They should probably be separated. I'm setting the names again. I'm just making everything look better. And I'm doing an assemble. I'm going to say, hey, this is going to go to simulation. This is also going to be simulated, because not everything is going to be simulated. Only the things I want are going to be simulated, which are these ones, and grouping them. Then on the other side, which are the big guys, I'm going to be boolean this with shatter. The difference is that before everything was merged, and later on I'm separating things that I want to separate, because the original tool was not meant for destruction. That's all about it. This is what I'm doing, separating things into different sections. Then again, just selecting what I want to simulate. Then I'm going to separate everything that's going to be simulated, which is sim. I'm going to unpack, and I'm going to set names again, and get the X, Y, and Z groups. This is just a wrangle that calculates where is it looking at. If it's looking, if X is bigger than Y and X is bigger than Z, then X is the angle, and the same for the Z and the same for the Y. So this will allow me, oh, I'm also, wait, this will allow me to detect what kind of fracture I want to make. The measure fracture, I'm just separating all the small pieces, which I don't need, which are a bunch. I'm going to set names again. I'm just resetting these guys here. And I'm going to split X, Y, and Z. And all I'm going to do is transforming in where I need. If this is X, I'm going to make this smaller on the X size. I'm going to sketch a bunch of points. I'm going to double on it, and I'm going to reset this. So now this is how you make wood, and this is made for all the angles, as you can see. Well, then I'm going to do the same trick, but instead of poly reducing, because I cannot poly reduce something that is already optimal, I'm going to just primitive this a little bit smaller so you don't have space and it's faster to simulate. Then this is just going to be saved. What I'm doing here is basically just splitting this, and this requires a little bit more transformation. I'm fusing the places that are quite a boogie, and I'm doing a Boolean fracture. This Boolean fracture is the places, it's basically the places where I'm going to have an explosion, if I'm not mistaken, which is down here. Yes, this shouldn't be changed. This is basically having some spheres based on the points, which are going to be at the later. I'm going to show you, and then I'm going to do a boolean. This boolean is, or are going to be some places which I found useful, or which I find that they're going to be simulated, because not everything is going to be simulated. Just these parts. This was selected precisely for what I wanted. I'm going to assemble these guys. I'm going to split again. I'm going to split for what I want. Firstly is this one. I'm going to unpack. I'm going to do another boolean. This boolean is going to be based on this of these wood planks. I'm going to pick it a little bit. It's very minimal, as you can see, to avoid some errors. I'm going to do the boolean. This is what I'm going to be getting. Shape of the wall. I'm going to be setting the names of each one. I'm going to be attribute copying the name original too. I'm going to be splitting based on the big numbers or the big names. With this, I'm going to do a group depending on the normals. Okay, poly extrude these guys. I might be getting some errors, which really bother me because nobody's going to see them. But if I clean this and I transfer again the attributes that I'm losing on the run, which is the name original too, reversing this, this is what I'm getting. If I do a for each piece, and again, the same trick, using the cutter trick I showed you guys, and the shutter boolean, this is the object that I'm going to be getting. If I do this for all the walls, this is the walls I'm getting. There are some errors, which probably is because I changed something here, but you shouldn't worry much about it. If I do a frustum, also I'm going to get what I need, and I'm going to blast everything that's not in camera. The same trick for this is the same trick for the what's the name, for the poly reduction, and this is the roof that I needed. Well, using this, I'm going to do the same trick, poly extrude, reverse. I'm going to boolean this based on, in this case, this part of the geometry, and I'm going to do the same trick of the cutter and the shutter boolean, which is just a copy to points with a bunch of cutters. This is the geometry I'm getting. I'm setting the names again, assembling this, doing the frustum that I want, and blasting everything that I'm not seeing, and doing the same trick, just saving this to disk. And finally, I'm getting all these roof tiles, which the only thing I'm doing here is to just delete everything that I don't need from the camera right here. I don't need all those roof tiles. I'm doing a poly reaction, of course, and I'm saving. And this is how the poly reaction looks. Now, this is the RBD part, so you can see it's a little bit messy, but it's depending on your geometry. I usually want to model everything so it works out of the box, not out of the box.